Hi, welcome to a new video about sine law and cosine law. This video will talk about the basics. What type of triangles use which law? How do we label the triangles to work with the formula? And how do we solve for both angles and sides for both cosine law and sine law? Why do we need sine law or cosine law? Well, that's easy. SOHCAHTOA is what we learned in grade 10, and with SOHCAHTOA, we need a right angle triangle so we can label our hypotenuse, our opposite, or adjacent, and use a sine, cosine, or tangent ratio. If you need more information about SOHCAHTOA, please see one of my previous videos. So if we're looking for an unknown side or angle in a triangle that's not a right triangle, we simply don't have the tools to do it. That's why we're going to use sine law or cosine law, depending on what information we're given and how we're able to label the triangle. All right, let's talk about the cosine law now. Have a look at the formula. A squared is equal to b squared plus c squared minus 2bc cos A. It looks a little bit scary, but it's actually not too bad. So a squared is the length of the side opposite angle A, as usual, and we're trying to find that. So we need these three pieces of information to help find it. Now notice how this looks like a little hat or a little brain, depending on how you label it. So that's the organization of the triangle. You need an angle surrounded by two sides. And if you're thinking about congruency, that would be the rule SAS. So you need a side, angle, side for that to happen. Then you just fill in the information. So b squared plus c squared minus 2bc cos A. Make sure in your calculator you do all of this as one unit, and then you add it on to b squared plus c squared. Now let's look at one more thing before we move on. You'll see in textbooks and other websites and other videos even that a lot of people relabel the triangle and they'll have formulas for b squared equals and c squared equals. Well, I like to cheat. I don't use these very often because I just relabel my triangle. So whenever I'm looking for a side, even if it's labeled as a B or a C in the other way the textbook has given it to you, I just cross it out, make the angle I have A, make the side I'm looking for a little a, and I use this one formula. Let's have a look and see how it goes. All right, let's have a look at this cosine law using the formula. And let's look at this triangle that we have. The first thing you want to look for is the pattern. Does it have the SAS or the hat? Well, this one clearly does. But what's also wrong with this one? Well, in my opinion, it's labeled incorrectly. So let's get rid of P and make it A with little a across. That's the unknown we're looking for. And these can become B and C. Nice thing about cosine law is really only A matters. Now, the next thing is always write down the square root while you're working through the question, because oftentimes it's a long formula, and when we get to the end of it, we forget to take the square root. So always put that down as a friendly reminder to yourself. So let's figure it out. A squared is equal to 13 squared plus 4 squared minus 2 times 13 times 4 times the cosine of 70 degrees. I apologize, it doesn't fit on one line. So please put this into your calculator in one go, and then add on 13 squared plus 4 squared, and you should get the square root of 149.42, and that is equal to 12.22 approximately. So 12.22 is the length of side A. That's really all there is to cosine law. Make sure you find your SAS or your hat, you plug it all in correctly, and you get your correct answer. All right, here's cosine law round 2. Again, we're looking at the SAS relationship. Is there the little hat? Yes, there is. Is this one labeled? No. Well, that's great as far as I'm concerned because I want to do my own labeling. So I'll make that A, that little a, this B, and this C. But remember, B and C don't really matter. Let's fill in our formula and see what it works out to be. All right, let's fill in our formula. Now notice that we have an angle of 35 degrees and our two side lengths are 400. So it's 375 squared plus 400 squared minus 2 times 375 times 400 times the cosine of 35 degrees. I apologize, I can never get it in one line. If you plug that into your calculator, remember to do this very carefully with the second half. Cos 35 times 400 times 375 times 2. Make it negative. Add 400 squared. Add 375 squared. You should get the square root of 54,879 and 37.37. And the square root of that is 234.26. In this case, that is meters. So just be very careful when you're plugging this into your calculator. Please do it until you get it right. And that's really all there is to the cosine law. Find your three parts, plug them into your calculator, use your calculator correctly, make sure you're in degree mode, and please don't forget to take the square root. All right, let's look at the last use of cosine law. It's finding an angle. Now, the cool thing about this is you can find an angle when you're given three sides. So notice that there's no other angles given. There's no two angles given to find the third one. We can't use SOHCAHTOA. We can't use sine law, so we have to find another way. So if you look at the formula for cosine law, you'll notice that there's a cos A tucked in at the end, and we used that in the last couple of slides. Now, we can isolate the variables for this and find out that cos A is actually equal to a squared minus b squared minus c squared, all divided by minus 2bc. Don't forget, when you use this formula, the very last piece is to do second function cosine of your answer, and that will magically give you your angle. All right, let's have a look at applying cosine law to a triangle. So here's a triangle, has sides 7.4, 11.6, 15.2. We'll just call it U for units. It can be whatever unit you want. We want to find the value of A, so we're going to use the rearranged formula for cosine A, and then we're going to label this as A, B, and C. And now it's just plug and play. We put in our 11.6 squared minus 7.4 squared minus 15.2 squared, all over in your calculator in brackets, minus 2 times 7.4 times 15.2. Now, remember, you have to use second function cosine of your answer. And when you do that, you get 47.75 degrees, or you can round up to 48 degrees. Only things you have to be careful of for this one is making sure you square everything on the top and that you have a really big bracket on the bottom to capture everything, or you do it in two parts. Try not to use your decimal places, or your answers could be a little bit different. That's it. That's using cosine law, given three sides to find an angle. All right, let's have a look at finding one last angle. We're going to try to find angle A, which is right here. And so therefore we know that this is little a, this should be capital A, and this is B and C. So again, we're using the cos A formula. Don't forget to use second function cosine at the very end to find your answer. So here we go. A squared is 16 squared minus 9 squared minus 19 squared, all over minus 2 times 9 times 19, all in brackets in your calculator. And I get 57 degrees. So there you have it. The key thing for cosine law is always label your triangle correctly, and always make sure you do the final last step. In finding the side, it's a square root, and in finding the angles, it's taking the second function cosine. So when I teach sine law and cosine law, the next natural question is, what about tangent law? Well, tangent law doesn't exist. So unfortunately, the tangent has a big sad face. So tangent only exists when we're using SOHCAHTOA in right angle triangles. You cannot use tangent for a not right angle triangle. So there you go. There's no tangent law. All right. You'll notice in the textbook that we're using that they split up the chapters into acute trigonometry and obtuse trigonometry. But when I teach it all together. Here's why. If we're looking at an acute angle, we know by definition that all angles are less than 90 degrees. If we're looking at an obtuse angle, at least one angle is 90 degrees. But guess what? When you're drawing loops, for sine law, or looking for hats for cosine law, it doesn't matter if it's an acute triangle or an obtuse triangle, the laws are applied the same. So sine law and cosine law, they don't discriminate against acute triangles or obtuse triangles. So there's the quick 1-2 of sine law and cosine law. So for sine law, make sure you find two loops, one that has the angle inside and one that has one of the unknowns. Please set up the ratios correctly. Sine A over little a equals sine B over B. Cross multiply to find the unknowns, and don't forget to do second function sine to find the missing angle. Cosine law, always look for the little hat on top of the triangle. It's a side angle side combo. And remember the second step, either square root to find the missing side or second function cosine to find the missing angle. And never forget, there is no such thing as tangent law. Thanks for listening. All right, let's have a look at the last piece of the puzzle. Which law should you use? Well, you have a right angle triangle. You know the only thing you can use is SOHCAHTOA. But wait, there's more. You can also use sine law. So the right angle triangles, you can also use sine law. Easiest way to approach it. So if you have these three things, a side, an angle, and a side, that would be cosine law. All right, if you have two things that you can put in loops, what law is that? Sine law. If you have three sides and you have to find an angle, what law is that? Cosine. Best use of cosine law is to find a missing angle given three sides. And last but not least, if you have a different arrangement, even if it's obtuse, you can still use sine law. So there you have it. Make sure you can know what law to use, and you have three choices: SOHCAHTOA, sine law, cosine law.